Bismillahirrahmanirrahim. Assalamu alaikum. Can you hear me properly? And the slides are also visible. So last time we started the discussion about the basic introduction of algorithm, and we see that if you want to write an algorithm, and that algorithm can be written in three different ways. Either you can use the natural language to write your algorithm, or you can use high language syntax, and the third way is the combination of both. Okay? So here we will go through some examples, and we see how we can write an algorithm. For example, one of the popular problem is GCD, calculating the greatest common divisor. So there are many ways to find the solution of GCD. For example, Euclid's algorithm is whenever you want to find a GCD, greatest common divisor of any two numbers, what you have to do, you will divide the first number with the second number, and whatever the remainder comes, that will become the second parameter. So this is a recursive definition of calculating the GCD. So this is the general formula on which this Euclid algorithm is based, and in this way you can calculate GCD. You can use also calculate GCD, for example, with prime factorization and other many ways. Okay, so if you are asked to write an algorithm to calculate the GCD, can you write it using this formula? If you are asked that this is a problem statement and you have to write a program, and before writing a program, if you are asked to write an algorithm, can you guys write it? Anyone? Is it difficult? You have already studied 2 programming courses, 202, 203. You have solved a lot of problems. You have completed a lot of assignments also. No one can write the algorithm for this problem. The question is, this is a problem that we want to calculate a GCD of 2 values using Euclid's algorithm. So if I ask you to write a proper algorithm for calculating the GCD of 2 numbers using this formula, can you write it or not? The question is very simple and straightforward. Can anybody write it on the chat? What you have to do? Okay, just tell me what would be the first step. This algorithm, this definition is recursive in nature. Okay, so if you remember, yes, this is a recursive. Do you remember how you can write a recursive algorithm? You need only 2 things. What could be the base case and what could be the solution for the base case? And if it is not the base case, otherwise what you should do is you need a generic formula. So generic formula is given. What could be the base case? Yes. Anyway, either you can write a code segment, or you can write a complete algorithm using natural language, or you can write a pseudocode. Okay, come on. I will show you one example. Yes, base case will be if n equal to 0. So this is an 2 example of writing this algorithm. First is which is using the natural language. So if n is 0, return m. This is the base case and stop. Otherwise, go to next step. And in next step, what you have to do, according to the given formula which I have shown you on the last slide, that we have to divide the first number with the second one. Okay. So whatever the remainder comes, that becomes the second parameter. So divide m by n and assign the value of the remainder to r. And next time, what you have to do, assign the value of n to m. And now you are changing the values, and the value of r to n. Just like according to the formula given here. First parameter was m and n, so n will be swapped to this one, and this remainder will become r. So this is how you can write an algorithm using natural language if you want to implement Euclid algorithms. The second way is code segment. Okay, more precisely speaking, it is a pseudocode, because you do not have a backward arrow operator in any high-level language. So, and even not have this symbol in any high-level language. So it could be a pseudocode. So while n is not equal to 0, what you have to do? You have to calculate m mod n and assign the value to r. Then swap the value. N value goes to m and r value goes to n. And this process will continue until n becomes 0. So either you can write it recursively or you can write it in this way iteratively. Is that clear? So these are just an example to elaborate how you can write an algorithm. The point to emphasize here is there is no fixed pattern in which you will write an algorithm. It depends on yourself and the way you are explaining the steps. The main point is whatever the characteristic we have studied last time, that it should be completed in finite time, it should be unambiguous, it should be written step by step, everything should be clearly understandable. So these are the main characteristics which should an algorithm have, and then it will be easy for a programmer to translate it into a program, okay, in executable form. Is that clear? So similarly, another way to calculate GCD, that is an other way out. This is not a Euclid algorithm, it is another way maybe you have already familiar with. You will find the minimum number, and according to the minimum number you will divide that value. If m is smaller, then you divide n by m. If n is smaller, then you can divide n by m. Is that clear? So first step is to assign the minimum value to t, then divide m by t, and if remainder is 0, then you have to go to step 3, otherwise you will go to step 4. And in this way, this algorithm will calculate the GCD. Other way to calculate the GCD could be that you can use prime factorization, as maybe you are familiar with the calculating the GCD using prime factorization. So this algorithm is based on that ideology. Is that clear? So similarly, you can find a lot of example in your textbook as well as in your reference book to see how the algorithm can be written. I'm giving you this exercise for this data set. You can find the way, find the prime number using this algorithm. So you can try it as an exercise for yourself, that if this algorithm is given, can we find the prime numbers which are greater than 2 and less than 20 for this given set of data. Okay, so this is your home exercise, and your answer should explain whether this algorithm is a correct algorithm and whether it is calculating the required values. Is that clear? So this is the basic introduction you should know about the algorithm. As I mentioned, there are 3 parts of this subject. One is the algorithm, which we have quickly gone through. What is the idea of algorithm? What is the problem statement? What could be the main characteristics of algorithm? And how we can write an algorithm if we found some problem statement. And we see a number of examples also that how we can write these algorithms. As a last punchline, by the end of the day, you should keep it in your mind, there is no one standard way of writing an algorithm. The only thing is, in whatever the way you have written the algorithm, that algorithm must be understandable, must be unambiguous, should be completed in finite time, and it should give a correct output. Is that clear? So now onwards, inshallah, we will discuss the other two factors of this course, which is analysis and design. So now coming to the introduction about the designing of the algorithm. Whenever you are going for this course, algorithm and analysis of and design, the first question pop up in your mind is what is the importance of this algorithms course, why we are studying it. One straightforward answer to this question is that this is the core part of your curriculum of computer science, so you have to study it. The second thing is, by studying this subject, you will be able to design a new solution for a new problem, as well as the solution which you have provided. Once you have solved a problem, that could be added to the database and that could be reused whenever the other user wants to use. Okay, so it will keep on creating a toolkit for other people, and if you are efficient enough to design an algorithm for unknown solution for any problem, then that algorithm could be added to that toolkit, added to that database, and that could be useful for other users. As you are familiar that during a data structure course, we have studied different standard algorithms like insertion sort, selection sort, bubble sort, merge sort. These are all standard algorithms which someone has invented, someone has developed, and now all the community are using those algorithms to solve their problem. So this is the second practical importance of this course. And obviously, being a programmer, you must know how to write an algorithm and how to write an efficient one. Is that clear? That's why it is very important course. You should be, after completing this course, you should have an capability to solve any problem and write an algorithm in a more appropriate way so that other users can use it. Okay. After writing an algorithm, the issue pop up is how you will design being as a programmer to solve that problem. Obviously, partially or mostly, or most time 80% of the design has been already described when writing the algorithm. Okay, and algorithm has something implicitly declared and defined, which is covering the design. Okay, but analysis portion, obviously after writing an algorithm, then the analysis portions come, and where you can analyze, where you can check whether this algorithm is efficient enough or not. Okay, so whenever we are discussing about the algorithm, we have to discuss with two aspects. One is how you will design the algorithm, what could be the design strategy to solve your problem, and the second is how you can analyze the algorithm, how you can determine the efficiency of the algorithm. First, briefly, we will go through the design introduction, and then we will first cover the analysis. After that, we will cover the analysis of the algorithm, and then we, in the second part of our course content, we will cover the different design issues, and we will compare these design issues with each other, which design which design pattern is better than the other one. Okay, so if we discuss about the design strategies which are available in the literature, There are plenty of design techniques are available. For example, the simplest one is brute force, then divide and conquer, decrease and conquer, transform and conquer, greedy approach, dynamic programming, iterative improvement, backtracking, and branch and bound technique. These are all algorithm designing technique. For 2 to 3, we will inshallah cover these techniques which are written on the left side, and these techniques which are written on the right side, that can be covered in 3 to 4. Okay, so our curriculum of this course will cover these approaches: brute force, divide and conquer, decrease and conquer, and transform and conquer. Is it clear? As I have mentioned, there are many algorithms which are already available in the literature, and they can be used as a standard algorithm which is related to, for example, sorting, searching, string processing, graph problem, geometric problem, and many more. Okay, you can find many standard algorithms to solve a problem related to these domains, and there are many other standard algorithms are available which can be used to solve a problem of anyone. And for every algorithm, whenever you are solving a problem, you need some data structures also, and we have extensively covered those data structure in our 204 course, which include the list, array, linked list, string, stacks, queues, priority queue, graph, trees, and set and dictionary. You have discussed this set and dictionary to some extent in discrete structures. Okay, so these are the different data structure which a language can use, and you can use these data structure to solve your problems. Okay, so up till this point we will not discuss in detail the design issue. So inshallah we will again restart this topic of designing an algorithm when we finish the topic of analysis. So now we will formally discuss about the analysis of an algorithm, and this will take, I think, almost 3 to 4 week time to discuss the analysis extensively. As I mentioned earlier, generally speaking, there are two types of algorithm. One is called iterative algorithm, and the other is called recursive algorithm. So in this portion of analysis of algorithm, we will discuss extensively the different ways, different techniques which are available in the literature for the analysis of algorithms. So any doubt, any question till now? So now starting with the analysis, whenever you are analyzing an algorithm, there are two basic parameters on the basis of which we can analyze an algorithm. These two parameters are the speed and the memory. Speed means how much time an algorithm can take to complete the execution and solve the problem. That is called speed of the algorithm. Or we also refer it as a running time or time efficiency. Okay, so an algorithm can be analyzed on the basis of its speed to determine how much time it will take to solve the problem. And the second aspect of algorithm analysis, second parameter on which an algorithm can be analyzed, is the memory. Memory means how much space it will occupy when it was solving a problem. So obviously this space occupation depends on the data structure which you have used, and similarly the running time is also dependent on the data structure which you have used. Okay, so when you are designing an algorithm, you have to consider this aspect also, that which algorithm, which data structure will be more beneficial in terms of its efficiency. And whenever you have an algorithm, that algorithm can be analyzed on the basis of two perspectives, on its speed as well as on its memory. Is it clear? Okay. Now this, if I talk what is the speed or the space efficiency, the memory or the space efficiency. So this space efficiency include each and every type of memory which it need to complete its execution. This memory could be the RAM, the memory which is occupied during execution of the problem, and the memory required in the RAM, as well as the disk storage. Is that clear? Whether it is permanent, whether it is temporarily, all memory cumulatively define what could be the space efficiency of that algorithm. Is that clear? So space efficiency will be the total requirement, which consists of the total real storage needed to execute the algorithm code and the storage to hold the application data. Whether it is input data, whether it is the process data, whether it is the output data, whatever the data and whatever the memory requirement it might need. Because, for example, if you are using a data structure during execution solving your problem, you might need extend the new node, but after some processing you may also deleting something. So during execution of program, your memory requirement is keep on changing. So whenever you are calculating the space efficiency, then you have to determine what could be the maximum space which it may require, and what could be the space utilization of the system during execution, whether it is storing a temporary data, whether it is using the permanent storage. Is that clear? Now the algorithm code, which is actually your instruction, set of instruction, that set of instruction always occupy a fixed size. That size will never change. Okay? And but when you are storing the value, then depending on your input and depending on the data structure, that size keep on varying during execution of a program. So these aspects are explicitly written here. For example, the storage requirement of the application depend on the nature of the data structure used. For example, if you are using array, then the size of the data will remain fixed. If you are using linked list, then it keep on changing during execution of program. Okay. The most important aspect about the space utilization is that nowadays, because the memory is easily available and sufficiently available, so our point of concern regarding the analysis of algorithm is not the space efficiency. Is it clear? Although the analysis can be described with respect to the space and with respect to the running time, but the space efficiency of any problem is not a big deal nowadays, because memory is easily available and it is sufficiently available. If you want to extend your data, you can easily extend it. Is it clear? And if we talk about the time efficiency, as name suggests, it is the time for which that is taken by the process, taking the input, processing it, and giving the output to the system. And usually that running time is represented by T of n. What is the meaning of T of n? N is the number of instances or the size of input. For example, if you are taking input for an array of 100 elements, so n will be 100. So T of n, whenever you are defining a running time, that is directly dependent on the number of your size of the input. Okay. So whenever we are talking about the running time, that will be described with respect to the number of input in that data structure. If you remember in analysis which we have performed informally in 204, at that time we have always discussed that if we have, for example, for linear search, we were talking about that if we have 10 elements, it will take 10 comparisons. If we have 100 elements, it will take 100 comparisons. And then we conclude that if we have n elements, then it will take n comparisons. and that's why it is called a linear search. Is that clear? Did you remember that? So the running time is always defined as a function of number of input, the size of the input, and it is usually represented by T of n. And some author also refer it as a time complexity. These are the interchangeable terms which you can find in different literature. Some user says it is running time, some says time complexity, some just use the word T of n. Okay. And for some complex type of algorithm like graph, that is not a direct relation with only input size, which is n, but sometimes it also depends on multiple parameters. Like in a graph related problem, usually the running time depends on the number of vertices and number of edges. Okay, so depending on your problem domain, these functionality of running time can be increased to 1, 2, or multiple parameters. Is it clear? And as I mentioned on the previous slide, that the space efficiency is not important nowadays. So analysis of the algorithm will, most of the time, 99.9% of time, will depend on its time complexity, how much time it is taking. So if an algorithm taking more time, but it is completing more space, but it is completing in less time, that algorithm will be more acceptable because the space is not an issue. The running time is more important. So we will pick an algorithm whose running time is better. Okay, is that clear? So time efficiency is more important as compared to memory. And if you want to write a running time of an algorithm in a proper way, and you have basic idea also when you are calculating the running time, as we have studied in 204, that the running time of any algorithm depend on the basic operation which is being carried out, and how many times, which depend on definitely on the input size, how many times this operation will be carried out. Okay, so if you remember the linear search or any searching algorithm which we have used there, that depend what is the basic operation and how many times this operation will be carried out, as I have given you an example just now about the linear search. So how you will represent it, how you will write it, T of n, as I mentioned, T of n is the running time for n input. That will be equal to the time taken by the basic operation, one single basic operation, and how many times this operation will be carried out. This will be multiplied by the execution time taken by an operation. So this is the general way of writing the running time of an algorithm. Is it clear? Any confusion, any question till now? So this is another example how you can determine the basic operation and what could be the size for that problem. For example, if you are searching for a key in a list of n items, so size will be n. Size of the problem will be n. And what could be the basic operation? Because we are searching, so the basic operation will be comparison. This is how you can determine from the statement or from the given algorithm what is the size and what is the basic operation. Analysis is very simple. If I say it, it will not be wrong that the analysis is simple, because all information is written in the algorithm and you have to just extract it and transform it into a more readable and understandable way. So this is the most tricky part, is extracting the information and concluding it with the precise way, in a precise way. Similarly, if your problem says you have to determine the multiplication of two matrices, so the size will depend on the dimension of the matrix. Okay, how many number of elements will be there. For example, if you say that there are two square matrices whose size is 4 by 4, so total number of elements for which you have to determine the multiplication will be, how much element will be there? if the dimension of each matrix is 4 by 4? What will be the size, input size? No, Sultan. No, Abdul Rahman. Whenever we are talking about, no. Whenever we are talking about the multiplication of two matrices, it means input size need two matrices to be input. And if one matrix is 4 by 4, 16 elements are in one matrix. So total size will be 16 plus 16, 32. Okay. So this is yes, 32. Okay. So it depends on the dimension. Be careful. Okay. And the basic operation will be their multiplication operation will be the basic. Similarly, if you want to check the 16 will be for one matrix, but for multiplication is a binary operator. Okay, so it needs two matrices. Similarly, if you want to determine the prime number, then the basic operation will be division, and it depends on the number of digits for which you have to determine the prime factor. It depends on the technique which you are using. Okay. So this is how, whenever you are analyzing an algorithm, you need two things only. What are the basic operation and how many times it could be applied. So this is the basic informal way to calculate the running time, and we have used this technique to analyze many algorithms in 204. So as we have discussed, there are only two basic parameters on which the analysis can be carried out for an algorithm. Fortunately or unfortunately, these parameters are inversely proportional. What does it mean? If you want to achieve good running time, it means the running time should be the minimum. Then you have to compromise on the space. You have to utilize more space, and you will see in coming algorithm, whenever we want to improve the running time, we have to sacrifice for that memory. And if you want to, you don't want to compromise on the space, then your running time will be increased. So it depends on your choice in the situation with which parameter you want to compromise, because it will inversely affect on the other. If you are saving the memory, it will take more time. If you are saving the time, it will occupy more memory. Is that clear? Because these two parameters are inversely proportional. It is very hard to find an algorithm for any problem in which you have optimal space, minimum space, and minimum running time. That will be really impossible. Okay, I can give you an example. For example, if you compare arrays and linked list, arrays, if you are using arrays, then it will be its processing time will be faster because you can directly access an element. But in linked list, what you have to do, you have to start scanning from first node, and you can reach it after traversing the list. Is that clear? So if you are using linked list, then it will take more time to access an element, whereas in array it will take less time. But you know that array is memory wise not efficient, because whether you have stored some data in the array or not, it will occupy the space. So we can say array is not efficient with respect to space utilization, but it is efficient to access the element because you can directly access it. Whereas linked list is memory wise efficient. Whenever you need a memory, you will create a node. But for processing time, it is less efficient as compared to array. Is that clear? So that's why we are saying that the speed and memory are inversely proportional. Any doubt? So whenever you are analyzing an algorithm, there are three different scenarios on which you conclude your results. Any algorithm can have best case scenario in which you achieve the best running time, minimum running time. Second could be the average case analysis in which the running time is, on average what could be the running time of that algorithm, that can be calculated. Okay, and the third is the worst case analysis. Worst case analysis means what could be the maximum to maximum running time of that algorithm. If you remember, again, I'm going back to the same example of linear search. At that time, we discussed that if we have 10 element, what could be the running time? If we 100, what could be the running time? And if the n element, what could be the running time? Okay. So what could be the maximum running time? Whatever the situation, whatever the type of data is stored in that will describe the worst case analysis. And similarly, there could be a situation, there could be a data in which you can get the minimum running time. That will be referred as best case analysis. And average case analysis means other than best and worst, whatever the data comes, that belongs to average case analysis. Is that clear? These three scenarios are clear to you? Best case scenario is in which you can get the minimum running time. Worst case scenario means in which you can get the worst maximum running time for that particular algorithm. Other than this best and worst, all scenario belongs to average case analysis. And generally speaking, this average case analysis and the worst case analysis result are the same. 99% of time, these results will be the same for one given algorithm. Only the best case could be slightly different than the worst and average. That's why we are only interested, usually whenever we are discussing an algorithm, we will discuss only the best case analysis and the worst case analysis, because whatever the result you have calculated for the worst case analysis, that is also applicable for the average case analysis. But if in some scenario, in some domain, in some problem, if it is different, then we can go for the third case scenario. Otherwise, for analysis, two scenarios are more than sufficient to describe the algorithm efficiency completely. Analyze that algorithm with the best scenario and with the worst scenario. Is it clear? Any question till now? So just in the previous lecture, as I mentioned that after every topic we have some review questions so that you can quickly go through the concept. And these questions are available on the slide. I am not going through these all questions individually. You can go through it yourself. So it is a good way to revise the concept and quickly revise the concept. Okay. So I'm leaving it for your own home exercise. You can go through these MCQs and you can build your concepts. The last thing before formally starting the analysis is some mathematical concepts. These are some basic concepts which you will use it again and again and again when we are talking about the analysis. So it is strongly recommended to memorize at least these concepts and because it will be used even not only in 2 to 3, it will also be useful for next coming course, which is 3 to 4. So if you are already familiar with these concepts and you have idea and how you can implement it, then it is fine. But if you have some weakness, you should cover it before starting the analysis. Okay? Do you know what is the sequence and series? Anyone? You have studied in discrete structure. What is sequence and what is series? So starting with sequence, what is sequence? If someone asks you what is the sequence? Yes, 1, 2, 3 is a sequence, but if someone say define it, how you can explain or define it? If you are defining the sequence is a series, it means sequence and series is the same thing. Abdul Rahman, do you think the series and sequence is the same? So how you can define a sequence with the term of series? So your example is right that 1, 2, 3, 4 is a sequence. If you have to define or you want to explain it to someone, so if there is a fixed pattern in the various in order, if there is some order, some pattern in the terms of the values in the values, then it is called a sequence. Okay, and usually whenever you are writing a sequence, the terms are separated using comma. This is a mathematical way to write a sequence. There must be some fixed pattern, and the second thing, whenever you are writing the sequence, the terms are separated by commas. And then what is the series? Series is nothing than else writing the plus sign between the terms. It means series will be the sum of the terms of a sequence. You understand the difference? Here you can see the sequence is, this is a sequence in which you have a fixed pattern, A 1, 2, 3, 4, 5 and up till n. Similarly, you can write a sequence of term in an abstract way, A1, A2, A3, A4 and so on. And how you will write the sequence? All terms will be separated by comma. Which type of sequence is this one? The last one, third one. Do you know the name? Anyone? Fibonacci. Yes, Fibonacci or Fibonacci, some pronounce it Fibonacci, but the spelling is double CI, okay, not CHI. So this is called sequence. And what is the series? The same sequence written with the plus sign. It means series will give you the sum of the terms of a sequence. Is that clear? So this is called series. 1 plus 2 plus 3 plus 4, this is a series. And this is also a series. This is also a series. Is that clear? Are you familiar with some type of series? Can you name any series? Yes. Abdul Rahman. Anyone know any type of the series? Are you familiar with arithmetic series? Anyone has ever heard the name arithmetic series? Sultan, have you ever heard the name arithmetic series? Geometric series, harmonic series? Not division. That is called harmonic series. No, I am talking about the basic type of the series. That are three types. Yes. That is very much important for analysis. Okay. So, for example, arithmetic series is 1 plus 2 plus 3 plus n. When the next term is created by adding something, some difference d from the previous term, that is called arithmetic series. If the next term can be calculated by multiplying some factor, that is called geometric series. And if the next term is calculated by dividing some value, that is called harmonic series. So these are the basic three type of series: arithmetic series, geometric series, and harmonic series. And whenever you are analyzing an algorithm, depending on the way the algorithm is written, you might encounter these series and you have to use some formula related to these series. And for 2 to 3 and most of the example which is included in 3 to 4 even, we will most of the time deal with the arithmetic series formulas. We rarely use the geometric series, but almost all example in 2 to 3 and 3 to 4 that can be analyzed only using the formula which cover the arithmetic series. Okay, so at least you should be familiar with the basic formulas for the arithmetic series. Okay, so if I want to know, do you know what is the general formula for arithmetic series? If I want to know the sum of this 1 plus 2 plus 3 till n, what will be the formula to calculate the sum of the series? For example, if I want to calculate the sum of 1 plus 2 plus 3 plus 4, what will be the sum? How you will calculate it? One way is just, yes, with sigma n. No, someone else? That is a representation. That is a representation to represent the. For example, if I want to represent this series with summation, okay, this is another question which I was not asking. So how you can write this series? This written as I equal to initialize with 1 up till n and summation I. I think you are familiar with this notation, isn't it? Ahmed, you are very close to the formula is not precisely correct. So you should know how to write the sigma notation. Okay, so if you are not familiar with this one, you should revise this concept. Okay, and the formula for arithmetic series is n into n plus 1 divided by 2. Right, Ahmed? So this is the correct formula. So please revise these summation formulas and the series. That will be really helpful in calculating the value. So at least you should know this formula for arithmetic series at least. Okay. K equal to 1 to n can be written as n into n plus 1 divided by 2. Okay. And similarly, for arithmetic series like this one, k square, it will be equal to this one. These formula will rarely be used, but this formula is very important, so learn this one. Okay. And please see what will be the effect on the formula if we change the limits. Okay. So if I, for example, if I write this series, up till n times, not sigma n, it will be sigma 1. It will be written like 1, I assign 1 till n. Okay, please revise this concept. I know you have studied it 1 year earlier in discrete structure, but please refer to those notes and you can memorize this formula. Yes, answer will be n. Yes, answer will be n. You are right. So these some formula I have given here. Okay. If you want to go extensively about these series and formulas, in your reference book there is an appendix C. You can find the complete list of log formula, summation, and all other basic mathematical formula which you might need for the analysis. Is it clear? So this is up to you. You have to revise this concept. Similarly, some formula, basic formula for log. If it is written log n, it means it is base 10. If it written like this one, lgn, then it means log base 2. So this is not a wrong way to write log. lgn means log base 2 and ln means log with base e. So these are some basic concepts, some basic formula related to log you must go through, and these formula you must understand and memorize before performing a good analysis for any algorithm. Is that clear? And some review questions related to these mathematical concepts are also given in form of MCQs. Okay, so please go through these slides before next lecture, and inshallah we will formally start the analysis topic next time. If you have any question till now, you can ask me. Otherwise, I will mark your attendance now. Is it clear? Please keep it in your mind, you have a lot of content in this course. So please do not keep on pending the task. Whatever I am saying you, please try to cover up before the next lecture. Because